So this is our last video series for exam 2. So this will be lesson 6. We're going to be looking at equations, solving equations with fractions. We're going to look at interchanging mixed numbers and improper fractions, and then just adding and subtracting with mixed numbers. So we'll look at the first part of this. As this is lesson 6, lesson 5, we actually looked at solving equations but leaving the fractions involved. And then we would end up dividing or multiplying both sides by the reciprocal. In this section, we're going to look at what we call clearing the fractions. So we're going to multiply by every term by the lowest common multiple so we can find a multiple of the equation, which would lead us to having only whole numbers in our answer. So if we're looking at this first one, we want to look and see, I've got 3, 5, and 5. So the LCM in this case would be 15. So what we're going to do is we're going to take the equation that we have and we're going to multiply the entire equation by 15. So we would multiply 15 to every term in the equation. So that would give us 15 thirds x plus 15 fifths equals 15 fifths x minus 15 times -1 would be -15. So then we're just going to simplify everything. So 15 thirds would be 5x, 15 fifths would be 3, 15 fifths would be 3x minus 15. So this is the nice part, is that now we have an equation to solve with only whole numbers. So I'm going to move my variable to the left side using inverse operations. I need that to go to 0. And I'm going to move my constant to the other side. So that will go to 0. So I'll have on the left side 5x minus 3x, which will be 2x. And then right here, we just need to be careful with our signs. That's going to be -15 and a -3, which would be -18. So then I'm going to divide both sides by 2. So x would equal -9. So that's the process that we're going to look at for several examples, is figuring out the LCM. And we're going to multiply that LCM by every term in the equation. Here's just another example. Zoom in a little bit and you can see just that process of 15 being multiplied to everything on both sides of the equation. And then you end up getting to your integer coefficients. And that's what integer coefficients, and then our constants are integers. So that's nice. It's a whole lot easier to solve. So let's look at some more here. So I've got 2 thirds plus x is equal to 4 fifths. So I'm thinking the LCM here would be 15. So we're going to multiply 15 by every term in the equation. So that'll be 15 times 2 thirds, 15 times x, and 15 times 4 fifths. So the way I wrote it now, you can kind of see that 3 will divide 15 5 times, so that would be 10. And this 5 will divide 15 3 times, so 3 times 4 would give me 12. So I'm going to subtract 10. So that'll be 15x is equal to 2. So divide both sides by 15. X is equal to 2 15ths. Let's look at the next one, which would be 3/4 x equals, all right, 3/4 x minus 1/8 equals a half. So 3/4 x minus 1/8 equals 1/2. And then I'm going to get the other one written over here as well. So that's 5 plus 9/2 x is equal to negative 7/2. All right, so we've got 4, 8, 2, so fourths, eighths, and halves as our denominators. So we're going to say that our LCM is going to be 8. So we're going to multiply everything by 8. So this is 8 times 3/4 x minus 8 times 1/8 equals 8 times 1/2. So we see the 4 will divide the 8 2 times, so 2 times 3x would be 6x. This 8 will divide this 8, leaving you just 1. And 2 will divide 8 4 times, so 4 times 1 is 4. So now we're down to only integers, and so I'm going to add 1. And so we would get 6x equal 5, divide both sides by 6, and you're going to get x is equal to 5/6. So the key is figuring out the LCM, then you're going to multiply every term by that LCM. And then it's a matter of just getting this correct, getting your multiplying of fractions and whole numbers correct in order to get to this point. All right, so now we look at 1. So our LCM would be 2. So we're going to multiply everything by 2. So this will be 5 times 2 plus 9/2 x times 2 is equal to negative 7/2 times 2. So this will be 5 times 2, that's going to be 10, plus these 2's will divide out, leaving you with 9x. And these 2's will divide out, leaving you with negative 7. So we're going to subtract 10, and that'll give us 9x is equal to negative 17. Divide by 9, so x would be negative 17/9. So again, figuring out the LCM of 2 and then getting this correct. Notice how I just wrote down 2 being multiplied by every term. I just wrote that down below here. And then doing the correct multiplying to get to the integers. So let's take this one here. We're going to multiply everything by 10. So this would be 10 times 1/2 x minus 10 times 1/5 is equal to 10 times 7/10. So this 2 will divide 10 5 times, so 5 times 1x is 5x. This 5 will divide 10 2 times, 2 times 1 is 2. This 10 will divide 10, leaving you with 7. Now we'll add 2. So 5x equals 9. So x is 9/5. This is thirds, halves, and fourths, so we'll say 12. 12 will be our LCM, so we multiply 12. So we're going to get 12 times negative 13/3 x minus 12 times 11/2 equals 12 times 35/4. So this 3 will divide 12 4 times, so 4 times negative 13 would be negative 52x. This 2 will divide this 12 6 times, so that'll be 6 times 11. And then this 4 will divide 12 3 times. And so that's 90 and 15. So that's 105. So we're back to integers. So I'm going to now add 66. That goes to 0. So negative 52x is equal to 171. And divide both sides by negative 52. So we'll say negative 171 divided by 52, which would be 3 and something as an answer, but that would be sufficient to leave it as that improper. So just kind of a review there, and that is figuring out when solving equations, it's just using that clearing method of the fraction. So it's all about figuring out what that LCM is and then multiplying it to all terms. All right, so let's look at the last part, is dealing with mixed numbers and being able to convert between mixed numbers and improper. So when you see something like this, you see the 2 and 6/7, these are actually written the same way. The 2 and 6/7 is actually 2 plus 6/7 because there's 7/7 and there's 7/7 and there's 6/7. So this would be 1 plus 1 plus 6/7, or 2 plus 6/7, which is the same as writing it as such. So let's take some of these. Let's look at a couple where we can look at some patterns, and then we'll see what we can always do to change from a mixed number to an improper. This 6 2/3, look at the denominator is in thirds, so you're going to have 6 3/3. So what will 6 groups of 3/3 represent? Well, that represents 6. But then we also have 1 2/3 at the end. So this is 3, 6, 9, 12, 15. This is 18 thirds plus the 2/3. Well, this 18 thirds, this 18 here, can come from multiplying your 6 and your 3. That gives you 18 thirds plus the 2 that are remaining, which would give you your 20 thirds. This 8 2/9 just means that there's 9 groups, or 8 groups of 9/9. And then there's one more 2/9. So this is 1, 2, 3, 4, 5, 6, 7, 8 groups of 9/9, which would be 72/9 plus 2 more ninths. That would give you 74/9. And so we can say right here that 8 groups of 9/9 is 72. So 8 times 9 is 72, plus the 2 would be 74/9. Negative 4 3/4. And we want to change that. Well, this would be, we know the answer is going to be negative. So 4 groups of 4/4 would be 16/4 plus 3 more. So 16/4 plus 3 more fourths would be 19/4. And we know that it's negative. Negative 7 5/6. We know it's negative. So think about, there's 7 groups of 6/6. So that's 42/6 plus 5 more 6, which would be 47/6, and we know it's negative. So when we're looking at converting from the other way, so if we have 7/3, we're just showing that we're thinking how many times will 3 divide 7, and that's 2 times with the remainder of 1, so we would say 2 and 1/3. So changing from improper to mixed number, you're doing the small division in order to change it. And then you're going to write your quotient and your remainder. So here we've got an exercise routine, and she jogged for 4 weeks. So we would have 24 plus 30 plus 27 plus 32. And we just want to know the average number. So we've got 4 weeks. So we've got 30, 40, 50, 70, 80, 90, and there's 100 and 13. So 113 divided by 4. So that will divide, what, 2 times? So this was how many, what was an average number per week would be 28 1/4 minutes per week. So when we found the 113 fourths, we don't usually write the minutes that way, so we'd go ahead and change that to a mixed number. And so you're asking how many times will the 4 divide 113, and so there's your long division that we did here. So now let's do that. Let's change each of these. So it's just a denominator divided into the numerator. So that would be 6 times. So that's 60. So that would be 6 and 9/10. Notice the remainder 9 going in the numerator, and the dividend or the divisor being in the denominator. How many times will 8 divide 122? Well, 8 will divide 12 tens 1/10 time. So 12 tens take away 8 tens is 4 tens. Bring down the 2 ones. So now 8 will divide 42, which would be looks like 5 times. So that's 40. So you're going to get 15 and 2/8, which we would like to simplify the 2/8 to be 1/4. Now these next two, we just know the answer is going to be negative. So how many times will 4 divide 9? 2 whole times. So it would be negative 2 and 1/4. How many times will 8 divide 50? We know the answer is going to be negative, so that would be 6 whole times. So this would be negative 6 and 2/8, which is negative 6 and 1/4. And then finally, we've got 4 will divide 227. 4 will divide 22 tens, 5 tens. There's 5 tens and 22 tens, so that would be 20. So 24 divides 27, which would be 6 times. So 56 and 3/4 is the same as 227 fourths. Now let's look at with mixed numbers. So with mixed numbers, you can't do this method with subtraction without going sometimes into negatives. But with the adding the mixed numbers, I would encourage you to add your whole number amount first. So 5 plus 4, that would be 9, and then come back and take your 3/4 and your 5/6 and add those together. And that would involve sometimes finding a common denominator, or a LCM. In this case, it would be 12. So you still find your n divided by n. So that'll be 10/12, which is an equivalent to 5/6. And this would be 3/3, which would be 9/12. And 9/12 is equivalent to 3/4. So this would be 19/12 plus 9. And we don't leave this 19/12 in that format. So we would divide. So we would have 9 plus 1 and 7/12, or 10 and 7/12. Now the thing with subtraction, like I said, if you do that process, you can see that you could subtract 7 minus 1, but the problem is now you got 1/4, take away 3/4, and that would end up putting you in a negative. So when we're working with, you can do this horizontally or you can do this vertically, and I'll show you in both ways here. So 7 and 1/4 take away 1 and 1/4. Well, I can't take away 3/4 from 1/4 without going into the negative. So I'm going to regroup here, and I'm going to take a whole. And the whole, remember, is 4/4. So I'm going to add 4/4 to the 1/4. And I don't have 7 wholes anymore, I have 6 wholes. So that's going to be 6 and 5/4, take away 1 and 3/4. Well, now I can do that. So 5/4 take away 3/4 would be 2/4. 6 take away 1 would be 5. And 5 and 2/4 would be the same as 5 and 1/2. If you want to look at this from the vertical standpoint, again, I can't take 3/4 from 1/4, so I'm going to come over here and I'm going to regroup, and I'm going to take a whole amount, which is 4/4. I'm going to add that to the 1/4. So that's going to give me 6 and 5/4, take away 1 and 3/4. And so this will be 5 and 2/4, or 5 1/2. So let's look at, okay, so we're adding here and here. So with this method, I'm going to take the 2 and the 6 and the whole amounts and make that 8. And then the 7/8 and the 5/8. Well, that's going to give me 12/8. And then 12/8 I want to change to a mixed number. So that would be 8 will divide 12 one whole time. So that would be 1 and 4/8, and 4/8 is the same as 1/2. So I have 8 plus 1 plus 1/2, or I have 9 1/2. Here I want to add the 4 and the 6, so that's going to give me 10 plus 3/8 plus 5/12. And I'm going to use 8ths and 12ths, so I'm going to make it 24ths. Those would be my LCM. So that'd be 10/24ths. And this would be multiplied by 3 divided by 3, so that'd be 9/24ths. And 9/24ths and 10/24ths would be 19/24ths. Plus the 10, so 10 and 19/24ths. So let's look at 5 and 1/8. Take away 2 and 3/8. So I can't take away 3/8 from 1/8 without going into the negative, so I'm going to regroup. I'm going to take a whole. A whole, remember in this case, is 8/8. So now it's going to be 4 and then 1/8 plus 8/8, which would be 4 and 9/8. And I'm taking away 2 and 3/8. So 9/8 take away 3/8 would be 6/8. 4 take away 2 is 2. And then 6/8, we want to simplify that to be 3/4. If you're looking at that from the horizontal standpoint, if you like this method, then you would still say I need to regroup. So that would be 8/8. So it'd be 4 and 9/8 because you would add these together. 4 and 9/8 take away 2 and 3/8. So 9/8 take away 3/8 would be 6/8. 4 take away 2 would be 2. 2 and 6/8 is equivalent to 2 and 3/4. So let's look at a couple with some fraction or with some negatives. So -4 and 1/6. And we want to add -5 and 2/9. So since they're both negative, we can add those together, and that's just going to give us -9. So we know our answer is going to be -9. So then what's 1/6 and 2/9? So that would be 1/18. So this would be 3/18 plus 4/18, which would be 7/18. So -9 and 7/18. Now, where it gets a little tricky and you got to be careful is when you see your signs that are subtract and negative. When you see the subtract and negative, you know that it's going to become a positive. And when you have -7 and 1/3 plus 5.5, now you're actually, remember, if your integer rules, if the signs are different, you're going to subtract and keep the sign of the largest absolute value. So you're actually going to subtract here. And so we've got -7 1/3 plus 5.5. And so what we're going to do here is we're going to change the thirds and the halves. We're going to make those sixths. So I need equivalent fractions. So 1/2 would be 3/6. 1/3 would be 2/6. Remember, when we have a -7 plus 5, we're really subtracting this. So I can't take away 3/6 from 2/6 without going to the negative. So I'm going to take one whole amount, and that whole would be 6/6. So I'm going to have -6 and 8/6 and 5 and 3/6. So 8/6 take away 3/6 would be 5/6. -6 plus 5 would be -1. So -1 and 5/6 for this one. Now there's another method of doing this. So let's look at -7 and 1/3 plus 5.5. And that is where you can actually change these to improper fractions. Now we already know this one's negative, so this is 7 times 3 is 21 plus 1 is 22/3, and that's negative. And the 5/2 would be 11 halves. So one's negative, one's positive. So let's get the LCMs to be the same, or find my LCM, which would be 6. So we're going to multiply -22/3 by 2 divided by 2. So that'll be -44/3. And this will be 33, not -44/3, but -44/6 plus 33/6. Now we can subtract these. So 44 take away 33 is 11, and the largest absolute value is this one. So it would be -11/6. And then if we divide to change the back to a mixed number, we already know the answer is negative, so this would divide one time. So we would get -1 and 5/6, which is what we found here as well. And so that's everything that for this video. We looked at solving equations with coefficients. We looked at changing from a mixed number to an improper, and then adding and subtracting fractions. So I would encourage you also to look at some of the practice from the practice links embedded in the slides.